All right, this is video lesson 413, laws of exponents. What we're going to do here is learn how to basically simplify any expression written with exponents using a couple properties. And if you look at this here, we have kind of a summary of the properties. I want to get right into doing the problems though, and so that you understand them, and I'll point it out as which property I actually use there when we get to it. So let's look at this first example, 10 to the negative fourth times 10 to the third. If I do that using what we already know about exponents, then we have 1 over 10 to the fourth times 10 to the third. And if I expand that out, that equals 10 to the third over 10 to the fourth, which equals 10 times 10 times 10 over 10 times 10 times 10 times 10. And 10 divided by 10 is 1, so there's 1 times that. There's another 1 time, there's another 1 time, and I'll just put an extra 1 here just so we know there's still a fraction there, but in the end we end up with 1/10. Because multiplying I canceled because I'm just multiplying by the number 1, and multiplying by 1 gives you the same result, which is really 1 over 10 to the first, which is 10 to the negative first. So this simplifies to 10 to the negative first. Now I did a lot of work to do that. And if you look closely and look at these two exponents, you'll notice that negative 4 plus 3 is equal to negative 1. So I really just added the exponents, and that's this law right here. If the bases are the same, you can just add the exponents. All right, the second one, we can use that same property. We have x to the third times x to the fourth. Now, if I forget about the property that I can just add those two together to get x to the seventh, I can expand it. There's my x to the third. Here's x to the fourth. And then I'm just multiplying those two together, and I can just add 1, 2, 3, 4, 5, 6, 7 factors of x, which I can write more simply as x to the seventh. All right? Again, I can use that property here. I want to deal with those exponents separately, so I really want to think about this as 5 times 2, and then times a to the third times a to the seventh. Now if I expand that out again, remember there's 3 factors of a there and 7 factors of a there. So I have a total of 10 factors, so I'm really just adding the powers together. 3 plus 7 is 10. So 5 times 2 is 10 times a, and I want to add the 3 plus 7, so I'm just going to say 10a to the 10th power. All right? This is a new kind of problem here where we have parentheses. 2 to the third, and then we're going to raise that to the second. Let's think about what this second part right here represents. What that says is I'm taking that number inside the parentheses and multiplying it by itself. So another way I can write this is just 2 to the third times 2 to the third. And then I can think about the last few problems we did where we just added the exponents together. I know that I have 3 factors of 2 here and 3 factors of 2 here, so I have a total of 6 factors of 2. So if I want to write it in exponential notation, that's the way I would write it. If I wanted it in standard form, then I would just figure out what 2 to the 6th power is. But for learning the laws of exponents, we're going to leave it in exponential form. So just add those 2 exponents together now. But one thing you might notice here also is that I had a 3 and a 2 to begin with, and I really had 3 that I had to add twice. And adding 3 twice is the same as multiplying 3 times 2, which just happens to be the 2 exponents, one inside the parentheses, one outside the parentheses. And that's really this property right here, called the power to a power law. So when you have a power inside parentheses, like b, and then a power outside the parentheses, you can just multiply those two. So if you remember that, Then when you look at this next problem here, you see a 2 inside and a 3 outside. So you can just multiply those, and that would be x to the 6th power. You also have to distribute this 3 with this 3 inside. So, and actually I'm going to expand it so you can see what I'm talking about. But this really means 3x squared times 3x squared times 3x squared. And you'll notice I have 3 multiplied by itself 3 times. That's 3 to the 3rd power. And then I have x squared multiplied by itself 3 times, which is x to the total of 6 factors of x. Now, if you look closely, what I could have done is just distribute that 3 with the 3 inside the parentheses. That makes 3 to the 3rd. And then to get the x power of x, I just multiply those two exponents. So 3 to the 3rd x 6 written in exponential form. You can simplify the 3 to the 3rd if you want. That actually equals the number 27, but for this, we're not going to do that. You just saw another product law, this one right here. Notice that if you have 2 different bases and they're raised to a certain power c, that's the same as the 2 numbers, the 2 bases multiplied together and then raised to the power of c. And we did that right here. We have 3 raised to the 3rd power and then x squared raised to the 3rd power. So we'll try one more of those right here. And I'll show you how this all works out in expanded form. But basically we need to raise this m squared to the 5th power. Okay, so we need to raise m to the 2nd to the power of 5 and n to the 4th to the power of 5. So that's going to look like this. M to the 2nd to the 5th and n to the 4th to the 5th. And now individually each of those, we're just going to multiply those. We're applying this power property, where one of the powers is inside the parentheses and another is out. So power to the power, you just multiply them. So that's m to the 10 and to the 20. Okay, now we also have some quotient laws. Let's take a look at those. So we have 10a to the 4th divided by 5a, and what I want to do here is expand this out so we can see what's going on, and then I'll suggest an easier way to do it. But so I'm just going to write this in expanded form, and then write the bottom in expanded form. Now remember, anytime we have a number divided by itself equals 1, so a divided by a, that's 1, and 1 times anything is just a number, so it's extra stuff. We can just cancel that. 10 divided by 5 is 2, and I'm just going to write that as 2. And notice what I haven't canceled. I haven't canceled 3 factors of a. So when I simplify this, I get 2a to the 3rd. Now if you look closely at what we have 10 divided by 5, which is 2. And notice, and think of this a, any number is the same as the number to the 1st power. So think about that. I had 4 factors of a on top and 1 on the bottom, and I canceled one of them. So I really had 1 less than the 4 I had on top, or 4 minus 1, so which is 3. So that suggests a quotient property, and our quotient law right here, that if we have the same base, a, and we have both of those bases to a power, and we're dividing those, we can just subtract the 2 powers. So we'll try that here on this one. So I have 12 divided by -4, which is -3. And then I have b to the 5th on top, b to the 6th on bottom. So if I apply that rule that I just had, I get b to the 5 minus 6. And 5 minus 6 is actually equal to -1. So that's one way I could write it. Now, if I didn't like that negative exponent there, which in some cases you won't want that negative exponent, then you have to remember how to deal with that. And b to the -1st is the same as 1 over b to the 1st, which is just 1 over b. So I could just write this as -3 times 1 over b, which using our fraction multiplication, that's -3 times 1 for the numerator. and 1 times b, which is b, the denominator. So that would be another way to write it if you couldn't use negative exponents. All right, now, just going to do a couple examples from this so we can get right to work on this. We're going to use these number charts to help us learn how to multiply exponents and divide exponents. And the way it works is you take a number from one of the rows, like this one, and this cell right here represents this number 3 to the second times this number in the same column. So the number we're going to get here is just 3 to the second times a. All right, so this spot right here will be represented by multiplying, and I know it's multiplying because of that symbol there, 2a to the third times a. Now that one, I'm going to want to simplify a little bit because I have the same base, and I can use the property that I just learned if you have the same base. So, and remember any number without an exponent is just the first power. So we have 2a to the third times a to the first, which is, go ahead and add those two numbers together. 3 plus 1 is 4. So that's 2a to the 4th. All right, and one more example of a division table. I'll show you how to use that. Here we go. Again, we are going to divide the row, these numbers, by the columns, these numbers, to get the number in the cell. So for this first cell right here, in green, I'm going to take 2a to the 4th divided by a to the 5th. Now, I've got a little room to work over here, so I'm going to put that over there. And the way I'm going to do that, I know that 2 divided by 2 is 1. So that's cool. And I'm going to use the quotient law, which says if I'm dividing powers and they have the same base, I just subtract the exponents. 4 minus 5 is my power of a. And 4 minus 5 is negative 1. Now, since I was multiplying 1 times any number is just a number, I don't need to write that. So right here, we have a to the negative first power. Ooh, I made a little bit of a mistake here. I thought we were dividing by 2a to the 5th, and we were actually just dividing by a to the 5th. So, so we really didn't, we're still going to have 2 here, and 2 here, and 2 there. Sorry about that. All right, so that's kind of what we're going to be doing tomorrow, learning how to simplify expressions using exponents.